All right, guys, welcome to the idea room slash work room slash sleepover room when my little brothers stay over slash video game slash getting away from everybody in the cat's room. And this is our first review video. Cool. I'm like so excited for this review. Can't even contain it in my black heart. It's going to review everything we've done this far. So all the way through module 8, and it's going to be a lot crammed into a little bit. And I'm not going in depth. This is like a general overview of everything you should know. So if you are unsure of anything, or if I don't mention something thoroughly, you might want to take a step back and go review that stuff. How about you take a step back and like keep on doing that until you're out of my life?
Because it's going to be on your big unit test here. So this is going to review binary, parts of the computer and how they communicate and the order they work in and all that stuff, and then go on to HTML and CSS stuff, okay? So I made a little diagram. I'm going to turn the iPad around and show you everything, how it should flow together.
All right. So, you are American, most likely. Did you just assume my nationality, bro? And you learned numbers like this, base 10. So, cool, you learned base 10. Oh my gosh, look at that. Precision. Nice camera. So you learned base 10. So if you wrote the number 453, what that means is that you have 4 10 to the second powers, and 10 times 10, or 10 to the second power is 100. So you had 4 100s, which is 400. Doi! You had 5 10 to the first powers, which is 10. So 5 times 10, you had 50. And then you had 3 10 to the 0 powers, and anything to the 0 power is 1. Ask your math teacher about that. I'm no longer a math teacher, but I'll be sure to share that information if you'd like. So I have 3 of these 1s, so that's 3, easy enough. So I have 400 plus 50 plus 3 equals my 453. Cool. Now, this is not how computers work, because computers, these guys, they need transistors, all right? They work off billions of transistors, and transistors don't have as many digits as we have in our base 10. We have 0 all the way through 9, so 10 digits. So 0 and then 1 through 9 would be 10 total digits. That's why it's called base 10. Whoa, what do you know? Now, a transistor only has 2 things. It can either be on or off, so it's base 2 that it has to use. And so we have to use binary. It's the same thing, same concept, except instead of powers of 10, it will be powers of 2. And so if you remember, the easiest way to remember is it just doubles. So 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, so on and so forth. Now, since we don't have 0 through 9 we can write in here, we only have 2 digits we can write in here, which is either a 0 or a 1. 1 being on, 0 being off. True, false. Transistor is allowing electricity through, not allowing electricity through. So let's say we write a number in binary. So I'm going to put this one on, I'm going to put this one off, and then these last 3 on. So this is 1, 2, 3, 4, 5 bits. So not quite a byte. Remember, a byte is 8 bits. So we have 1 2 to the 4th power. So I have 1 16. So I have a 16 here. I have 0. It's off. I have no 8s. So there's nothing to add here. I have 1 2 to the 2nd power. 2 times 2 is 4. So I have 1 4. I have 1 2 to the 1st power, which is 2, so I have 1 2. And then I have 1 2 to the 0 power, which is 1. Anything to the 0 power is 1, so I have 1 here. So this number in binary, if I add all these up, so 16 plus 0 plus 4 plus 2 plus 1 would tell me what the number is. So 16 plus 4 is 20, plus 2 is 22, plus 1 is 23. So 1 0 1 1 1 is the equivalent to 23. All right. So from there, why do we need to know that? Well, because every part of a computer talks to each other in, let me guess, binary? Binary. So they send information back and forth in a bunch of zeros and ones. So information comes into the BIOS, goes to the CPU. The CPU checks memory for programs. There's some bugs in there, most likely all the time. Oh my gosh, close up of the fingernails, jeez. All right, and these are all communicating in binary. And so we don't have to know how they're communicating, but it is beneficial as a program to understand what's going on and truly appreciate how much information is being transmitted back and forth. So let's say you click a mouse. Well, the mouse goes through the basic input-output system, the BIOS. The CPU says, okay, well, what is this mouse over? What is the program for the mouse? So it checks memory, gets the programs, sends it back to the CPU. The CPU says, cool, what's next? So it checks the programs again, sends it back, so on and so forth. Hopefully there's no bugs in there. Cool. So binary is how the parts of a computer communicate. Now, luckily, we don't have to know binary off the top of our heads. We need to know how to calculate it just to be good computer scientists, but we don't need to know it off the top of our heads because they have something called encoding. And there are many different types of encoding. We usually have seen Unicode, the UTF-8, whenever we're doing Khan Academy stuff and making HTML websites. And what that does is it puts these glyphs, which you call letters, so these letters and symbols here, these glyphs, so it could be exclamation mark, periods, semicolons, quotation marks, all that good stuff. They set each glyph to have a specific number. So if we want to write the letter A using a certain type of encoding, it might be 36. So we would go write 36 in binary. So we'd have a 32 plus a 4, that'd be 36, that'd be 100100. And when we send out to a computer, the computer would check its encoding and say, hey, 36, that's an A, and it would display an A on the screen or send an A or whatever we want. Now, A is not always 36. This was just an example I made with this encoding. There are many different types of encoding. We use Mr. Leclerc's coding, which
I made up. It's not real.
Now, from there, okay, we got lucky and we can write programs in certain languages. And instead of us having to worry about encoding or binary, the programs we can run through a compiler. And the compiler will put those into the machine language. So whatever type of encoding, binary, whatever the situation calls for. So these programs that we write will be in some language, like our first pseudo program that we were talking about, which is HTML and CSS. We'll get more into JavaScript and Swift and all that stuff later. That way, when we're writing these, we don't have to think of ones and zeros or this encoding. It's good to be aware of it, we just don't have to be responsible for it. Now, in order to write these programs, it's a good idea to know how the parts of a computer, like the monitor and the mouse, operate. So a monitor is just like a graph in math. So in math, you guys, if I have to learn about math, not in math class, one more time, I'm going to drink like 17 monsters
and tear this place apart.
Have a coordinate plane which has an x-axis and a y-axis, and you start at 0, 0 right here. And your teacher probably says, oh, you got to run to the elevator before you go up and down, or you got to walk before you can jump, or whatever the case may be. Now, what we do is we use this kind of basic concept, but we got it flipped and altered a little bit. So our purposes call for calling this top left corner 0, 0. And then as we go this way, on the x-axis, the numbers get larger. And as we go this way, on the y-axis, the numbers get larger. So we don't have any negative numbers.
I can't stand negative numbers.
That was pretty much the goal here. And plus we read from top left across and then down the page. So kind of makes sense. So if we want to put a button or a picture or something on a monitor, we have to tell it where we want this object to be. So in this case, it might be over 100 pixels down 200 pixels. So this would be 100, 200. So we can place this button or image or whatever we want at this location. Now a lot of different things can happen here. But what we can do with a mouse is the mouse is always keeping track of its X and Y location. So if we move the mouse and it happens to hover over this button and then we click down, the information will go. The CPU will check memory to see what it's supposed to do if the mouse is clicked over this button, and then it will run that program. So if we click the mouse off to the side of the button where it's not registering, well, there might not be anything in the program for that, and so nothing will happen, which I'm sure you've missed a button when you've thought you've clicked it before, especially on a phone where you're tapping with your finger instead. So that's basically how these two things go together. We put pictures, buttons, any canvases, programs, windows on the screen using this concept. Start at the top left 0, 0, work on the X axis first, that's the first number, then how much it goes down on the Y axis next. And the mouse continuously monitors that location, so in case you click on something on the screen, the program will tell the computer what to do if your mouse is clicked over a certain part of the screen, like we've done in HTML. So, what's next?